So now in this video, I will be discussing the different types of organic compounds. Okay. So most of the times I will be keeping my video off here because I need to use the full screen so that I can show you in the form of a flow chart how you can memorize the types of organic compounds simply in a simple way. Okay, easily. So I'm sharing my screen with you, turning my video off. Okay, now organic compounds, the simplest organic compounds are the hydrocarbons. So we are now moving into the classification of organic compounds. Simplest are the hydrocarbons. Simplest organic compounds are the hydrocarbons, and all other organic compounds are derivatives of hydrocarbons in which one or more hydrogen atoms have been replaced by other groups or atoms, right? So let us move into it. So here we can write the organic compounds. So these are of two types on a broad way. These are open chain organic compounds or acyclic organic compounds. Open chain or acyclic organic compounds. Now further, if we divide these organic compounds, they can be classified into further two more categories: straight chain organic compounds and branched chain organic compounds. Straight chain and branched chain organic compounds. So if the chain is straight, there is no branching, it is a straight chain organic compound, like CH4. It is having only one carbon, even branching cannot occur. When it is a two carbon compound, if we take CH3, that is ethane, even in this case also, no branching can occur. In propane, there cannot be any branching. So up to the 3 carbon atoms, branching cannot occur. Okay, when we have 4 carbon atoms, 4 or more carbon atoms in the open chain organic compounds, then there can be branching. Now if we see the straight chain compound, organic compound, which is having 4 carbon atoms, it is butane. Now it can be branched also. How to write it? With branching. Now same molecular formula, but a different compound is there. This is N-butane and this is isobutane. Now this is branched chain. Isobutane is branched chain. So pentane can be straight chain, 5 carbon compound. It is N-pentane. It can be branched chain also, which is neopentane. Neopentane. So after after 3 carbons, there can be branching. So up to when we have only 3 carbons in the chain, there cannot be any kind of branching, right? So this is the classification of open chain or acyclic organic compounds. Then second type is closed chain or cyclic or ring compounds. Closed chain or cyclic or ring compounds. Ring compounds, right? Now in this, we can further categorize it into 2 categories. One is carbocyclic or homocyclic. Carbocyclic or homocyclic. This means there will be only carbon atoms in the ring. Only carbon atoms in the ring. Then we have heterocyclic. Heterocyclic. Now, in case of heterocyclic ring compounds, that is ring organic compounds, there will be a ring which will contain carbon atoms, but along with carbon atoms, at one or more positions, there will be some other atom. And the other atom can be either nitrogen or oxygen or sulfur. These three can be there. So in addition to carbon, there will be one or more heteroatoms. That is, the ring is not formed only by carbon. It is also containing either nitrogen, oxygen, or sulfur. Clear? Then these carbocyclic compounds, they can be further classified into Elecyclic and Aromatic. Elecyclic and Aromatic. Now, Elecyclic means there will be a ring of 3 or more carbon atoms. Ring of 3 or more carbon atoms. For example, if we take 3 carbon ring, CH2, CH2, CH2 in a ring, then we can take cyclohexane, that is the 6 carbon atoms in the ring are there. Six carbon atoms in the ring. So these are Elecyclic. Now these are not aromatic, these are not open chain, these are Elecyclic, but they have properties similar to those of the open chain compounds. Properties are similar to open chain compounds. Open chain compounds. Okay, now the aromatic. In case of aromatic compounds, there will be at least one benzene ring. At least one benzene ring will be there. More can be there, but it should have at least one benzene ring. So here the examples will be, we can write benzene itself. Then we can write benzoic acid. We can write aniline. So these are the compounds which are aromatic compounds which have at least one benzene ring in them. So now I need to erase it so that I can write more. So I will be erasing some of the parts so that I can get more space. Okay. So this is aromatic we are discussing. Hope you are taking lots of notes. Okay, do not do it without taking notes. So now the aromatic compounds, they can be classified further into 2 categories. Aromatic compounds can be classified further into 2 categories. One is benzenoid. The other one is non-benzenoid. Benzenoid, non-benzenoid. What is the meaning of benzenoid? Benzenoid means like benzene. Oid means like, similar to benzene. So in case of benzenoid, we will be having at least one benzene ring in that compound, right? And now it can be further classified into 2. Benzenoid compounds will be having at least one benzene ring. They can have more also. If there are more number of benzene rings, that is more than one benzene ring is there, then it can be a fused ring compound. Fused ring compound, or it can be a isolated benzenoid compound having more than one benzene ring. So if the rings are fused together, it is known as polycyclic. Polycyclic. Okay. Now the examples here are naphthalene. So it is having two benzene rings fused together. Anthracene is there, in which there are three benzene rings fused together. Anthracene. So this is naphthalene, and this is anthracene. Okay. Now, in case of isolated benzenoid compounds, here there will be two benzene rings are there, but they are not fused together, but they are joined together with an additional bond. I just need to undo this. Just wait a while, okay? Eraser. Okay, now here we have this benzene ring, one benzene ring, and the other benzene ring. They are joined together by a bond. Joined together by a bond. This is isolated, right? Now this is biphenyl or diphenyl. This compound's name is biphenyl or diphenyl. If three benzene rings are fused together, not fused, sorry, if they are joined together, fused together, we have already done, it is anthracene. If three benzene rings are fused, now it is isolated benzene rings are there. Now the name of this compound is terphenyl. Terphenyl. Three benzene rings are joined together, but they are isolated. They are not fused. Okay. So these are the benzenoid compounds, that is the compounds having at least one benzene ring in their structure. Okay, so now I'm erasing this. So next is non-benzenoid compounds. Non-benzenoid compounds are the compounds which are aromatic. They have the properties of aromatic compounds, but they do not have any benzene ring in them. They do not have any benzene ring in them. For example, if we have this compound which is having 7 members in the ring, 7 carbons are there in the ring, and there is a carbon oxygen double bond here. Here is a double bond, here is a double bond, here is a double bond. So there are 7 carbons in the ring. If you count, there are 7. 1, 2, 3, 4, 5, 6, 7. 7 carbons are there in the ring. So the name of this compound is tropolone. Tropone. It is tropone. Tropolone is different when there is OH group also attached. So this is tropone. Now, if there is an OH group attached to the ring, so there should be 7 members. Okay, just count it and draw it neatly. Right? So this is tropolone. So this is non-benzenoid. It is not having any benzene ring, but still it is aromatic. Okay, clear? So next is we need to write the examples of the heterocyclic compounds. Heterocyclic compounds are the compounds in which the ring is there, but not all the members of the ring are carbon, but there can be other atoms also which the other atoms can be either nitrogen, oxygen, or sulfur. So I'm erasing it from here so that I can write the examples of heterocyclic compounds. Now in tropone and in tropolone, there is carbon oxygen double bond, but the oxygen is not part of the ring. Okay, so it will not be considered as heterocyclic. In heterocyclic compounds, the heteroatom will be the part of the ring, right? So now we are taking the examples. The very first example is THF. THF is tetrahydrofuran. Tetrahydrofuran. So it is like this: CH2, 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 and oxygen. Okay, then the next example is furan. In case of furan, we have this ring. Hope you can write the carbon atoms. So it is CH, 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 CH. So this is furan. Okay, then there is pyrrole. In case of pyrrole, nitrogen is the heteroatom present. Pyrrole. Then there is thiophene. Thiophene. Whenever the word thio is used, it means there will be sulfur in the compound. So this is thiophene. Right? Then last one, pyridine. I'm not saying that these are the only heterocyclic compounds. There are a lot more heterocyclic compounds, but the examples here we are writing these many. Pyridine. Okay. So note this down. You can pause the video, watch it again, and just have hands on to the different types of organic compounds. So this is the classification of organic compounds. So I'm back, right? So I think you have understood what are the different types of organic compounds and what is a heterocyclic compound, what is a cyclic compound, what is Elecyclic compound. So students, they tend to forget it. Okay, just have this flow chart with you. Okay, you will always be having these things in your mind, that what are the different types of organic compounds. I will see you in the next video.